graphs where Dijkstra fails, workouts that don't get skipped, language streaks that don't break. Today, Bellman, Ford, 2 LeetCode graph traps, a heavy pull session, logistic regression fundamentals, trading, and Einstein, all in one discipline day. Don't blink. The first lesson saves you from a classic mistake. In today's lecture, we discuss the Bellman-Ford algorithm. Bellman-Ford is a shortest path algorithm used on weighted directed graphs, and the key reason we use it is because it can handle negative edge weights. Unlike Dijkstra, Bellman-Ford does not assume all weights are non-negative. It works by repeatedly relaxing all edges and updating distances, and after v-1 iterations, it guarantees the shortest paths. An added advantage is that it can also detect negative weight cycles, which Dijkstra simply cannot handle. The trade-off is time complexity. Bellman-Ford runs in O v times z, which is slower, but when negative weights exist, Dijkstra is simply not an option, so Bellman-Ford becomes the correct choice. After that, we moved on to minimum spanning trees. A minimum spanning tree is a way of connecting all vertices of a connected, weighted, undirected graph such that there are no cycles and the total edge weight is minimum. It connects all nodes, uses exactly v-1 edges, has the minimum possible total weight, follows the cut and cycle properties, and if all edge weights are distinct, the MST is unique. Understanding these properties is crucial because MST problems are not shortest path problems. They're about global optimal structure, not distances from source. Once the theory was done, I moved straight to LeetCode to put into practice. The first problem I tackled was minimum cost to connect all points. Given a set of points on a plane, the task is to connect them with the minimum possible total cost, where the cost between 2 points is their distance. This naturally maps to a minimum spanning tree problem. And while both Prim's and Kruskal's algorithms work, Prim's algorithm is especially effective here. The graph is dense, so we can compute distances on the fly without explicitly building all edges. Starting from any point, we repeatedly add the cheapest edge that brings in a new point until all points are connected. The second problem was cheapest flights within K-stops. In this case, we're given flights with costs, a source city, a destination city, and a maximum of K-stops, and we need to find the cheapest valid route. This is where Bellman-Ford shines. By restricting the number of edge relaxations to K+1 iterations, we ensure that only paths with at most K-stops are considered. Each iteration allows one more edge in the path, and after K+1 passes, we get the minimum cost that satisfies the constraint, simple, elegant, and hard to mess up. You can see the screenshots of both the codes getting successfully submitted, and both were of medium difficulty. After algorithms, I moved on to my daily language practice. Today was German, and I extended my streak to day 252. This session was focused on revision, reinforcing previously learned vocabulary and concepts so they stay sharp over time. All the exercises were built around earlier topics, and by the end, I completed all 3 daily quests and climbed to first place on the weekly leaderboard. It was a focused, satisfying session that felt productive rather than rushed. After that, it was time for the gym, and today was pull day. For back, I worked through lat pull-downs on the seated closed grip machine, seated wide grip machine rows, barbell shrugs, lat pullovers, and good mornings for the lower back, 2 sets each. For biceps, I followed up with cable curls, hammer preacher curls, and preacher curls, again 2 sets each. The workout hit back width, thickness, and lower back support while also targeting all heads of the biceps. Overall, it felt well-balanced, controlled, and exactly the kind of session that adds up over time. After the gym, I continued reading Einstein, His Life and Universe by Walter Isaacson. In this session, I read about Einstein's views during World War I and the intense race to general relativity. Einstein was deeply anti-war and believed conflict corrupted human progress. He even disliked chess because of its adversarial nature. While some of his colleagues like Max Planck, Walther Nernst, and Fritz Haber supported the war and redirected scientific research toward weapons, moreover, Haber eventually made a chemical weapon which was used on 5,000 Belgians and French to put them in a forever sleep. Einstein stood firmly against it. During the race to general relativity, He and David Hilbert were pushing each other hard, exchanging letters and pointing out flaws. Hilbert was extremely close, but Einstein returned to tensor mathematics, refined his equations, and published the correct theory just days before Hilbert. Despite the rivalry, they eventually reconciled and remained respectful colleagues, which was a powerful reminder about competition without bitterness. Later in the day, I moved to trading. After blowing my funded account the previous week, I bought a new $5,000 funded account and went short on gold based on my technical bias. I missed a key U.S. Venezuela geopolitical development, and as uncertainty rose, gold pushed up almost immediately. I reassessed and exited with a $26 loss. The loss was small, but the lesson was clear. Technical analysis alone isn't enough. News can invalidate even clean setups fast. After that, I shifted into my machine learning session, diving into logistic regression, but not in a formula-first, rush-through-it way. I slowed down and rebuilt it from the ground up using StatQuest, focusing on intuition before touching any math. The goal wasn't to memorize equations, but to understand why they exist. It started with probability versus odds. Probability tells you how likely something is, but odds show how success stacks up against failure. A probability of 0.8 isn't just high. It means 4 successes for every 1 failure, while 0.2 flips that to 1 success for every 4 failures. That ratio-based thinking highlights relative strength instead of a cramped number between 0 and 1. It makes multiplicative effects easier to reason about. Then came log odds, which was the real unlock. Taking the log stretches probabilities from a tight 0 to 1 range into a clean scale from -infinity to +infinity, introducing symmetry between strong yes and strong no. This is why logistic regression doesn't predict probability directly. It predicts log odds linearly and then converts them back into probabilities using the sigmoid. That pipeline suddenly felt inevitable rather than arbitrary. Finally, maximum likelihood tied everything together. Instead of fitting parameters by guessing, the model asks a clear question: which parameter values make the data I already observed most probable? For every data point, the model assigns a probability to the correct outcome, multiplies all those probabilities together, and then adjusts the parameters to maximize that total likelihood. Confident correct predictions increase this likelihood, while confident wrong predictions sharply decrease it. When we take the log of this likelihood, it naturally becomes the cross-entropy loss used to train logistic regression. I watched the videos slowly, paused often, and made handwritten notes alongside them to connect intuition with math. By the end, logistic regression wasn't a black box anymore. It felt like a clean, well-engineered system built on simple ideas. To wrap up the day, I shifted into quant prep, focusing on relations, numbers, and functions, the kind of material that quietly sharpens how you think. I revisited rational, irrational, and complex numbers, not just as definitions, but through their deeper properties. Rational numbers, despite feeling infinite, are countable. Real numbers explode into the uncountable, and complex numbers, surprisingly, share the same cardinality as the reals. It's the kind of idea that stretches intuition and forces you to think beyond calculators and shortcuts. This session leaned heavily into proofs and theory, but that's exactly why it matters. It builds the mental scaffolding needed for serious quant reasoning later on. That was my full day 23, deep DSA concepts, applied problem solving, language discipline, physical training, serious reading, a trading lesson, machine learning fundamentals, and quant prep. If you're still watching, you're not just consuming content. You're practicing consistency, the kind that compounds quietly and pays off over time.
The network awakens. Intelligence takes form. Undegreed. The signature remains.